Thanks everyone for joining my talk. It's a real pleasure to be at this conference. My only regret is that I couldn't be there with you all in person. Champaign was actually my UIUC was actually my first faculty job when I graduated, and I spent 3 years from 2006 to 2009. And now I'm at UC Berkeley. So I still have a fond place in my heart for UIUC. And I was just chatting with Brendan earlier. Apparently there's a lot of changes on campus in the last 10 years, not surprisingly. I think the last time I was there was about 4 or 5 years ago. So yeah, but you know, it's still great to be able to share this work with you all. I think you know, everybody who's using Mathematica would be you know, cognizant of some of the issues that I'm talking about, and hopefully it'll kind of give you a sense of what both the social and the biological sciences could tell us about some of the you know, these really urgent social problems that we're facing with you know, the growing popularity of AI tools and systems out there. So what I'll be talking about is a set of questions related to, you know, things that you will see in the news a lot these days. So these are, I just grabbed some headlines from both older and newer newspapers, and I think it really helps illustrate that a set of problems that I think for most humans are pretty easy. You don't have to have any special expertise. You can just be, you know, a regular human being, and you would find these questions quite simple to solve, or at least understand. But they are still really difficult for machines. And these are things like about biases in AI systems, and any kind of large, you know, data repository that reflects kind of human society is going to is very likely to contain kind of human biases that today we consider harmful. And if we're depending on these machines to make decisions for us, or to, you know, run the economy in some in various different aspects, there's of course a fear that they will either replicate or exacerbate even these previous issues. So, you know, this is from a few days ago, and you know, probably most of you would have heard about this, if not seen the, I think 60 Minutes did a piece on it, and it was kind of all over the news in terms of the in terms of the congressional hearings, in terms of the Facebook and kind of different ideas about hate speech, and how do we moderate and control and prevent kind of the spread of hate speech. And one of the issues that all of the tech companies face, and actually not just tech companies, all of society faces today, is, you know, how do we put a definition on what is acceptable and unacceptable speech? And part of this is, and even you know, what is fake news and what is real news? So these are really difficult questions. And I think one of the things that, at least as I talk to people in tech, either in Silicon Valley, because I'm at UC Berkeley, so I know a lot of folks who work in tech, some of them who are working on this very problem. One of the big challenges is kind of thinking in terms of language or fake news as just as an issue about truth and falsehoods, right? So it's a lie or it's truth. And that's really, I think, a much too restrictive definition of what, you know, sort of quote unquote problematic or hate speech or fake news is. And then I'm going to illustrate this with a headline from the right. So this is a Breitbart article from a few years ago. Most of you, I can't imagine any of you, but you know, maybe some of you read Breitbart. You know, I make no judgments. But they are fond of running headlines like the following. So this is, you know, just a pretty random one that I picked. Illegal immigrant charged in murder of a Texas woman, right? So it's not necessarily wrong. In fact, I didn't do this. I didn't check whether this actually happened, but you could easily imagine that this was an actual event, right? So in terms of kind of thinking about this in a scientific way or in a social scientific way, the problem really isn't always about saying, the sky is green or the earth is flat, right? It's really about giving those are obviously, wrong, but the harder ones to tell, the harder kind of issues are kind of unrepresentative type of information or language that is, unrepresentative of the real world. So if every headline I read is about, something terrible happening that's done by illegal immigrants, everything there could be true, but it doesn't make it okay, right? So whether we want to ban that, whether we don't want to ban that, that's a separate question, right? But what we want to do is kind of put a kind of a quantitative framework around the idea of how do we measure something like bias. And the issue is, I think for many people in tech, you probably would have heard of the I think apocryphal phrase by I think it's often attributed to Deming, that if you can't measure something, you can't manage it. So I think it's very much about these sort of issues with how do we measure, and then using kind of that information, then we can kind of shape policies around it or just understand what is going on, right? So what we want to have ideally is a system that is able to perceive the social world and make social actions, and in a way that is not possible right now. So some of the challenges that we have to confront is that the system, so if we want to make social actions and we want to perceive the social world, we want to be able to say whether that social perception is correct, biased, representative, or having some benchmarks and metrics for those social perception. That's often really difficult. We also want a system that can generalize, because the social world can be really fluid. So we don't want to just, we want to kind of, as a person, if you're raising a child, you want to teach the kid, the right lessons about how to behave, and then you want to, set your kid loose in the real world, and hopefully it'll make kind of good decisions, right? Like that's kind of, I think, one of the hopes that we want kind of these systems to exhibit, that it can make decisions by weighing the appropriate costs and benefits. And also that they can be corrected, right? And right now, the systems that we have kind of can't do any of these, in part because it doesn't know what the social world is. It can't perceive it. It doesn't make decisions by weighing the consequences. And we have no idea really how to correct it either. So what I'm going to hope to show you is that we have at least some sense of being able to create a system that can use data that's out there that we know are, biased and some cases problematic. And using that biased data, we can learn about these biases, right? So to understand, to be able to correct these biases, we have to understand them. We have to understand, like, what does, say, the news, what biases that we create in the news, and how people think about other people. We can generalize to novel social groups or to novel situations. We want a system that can behave similarly to both humans, as humans do, in both the lab and the field. Right? So this way we can say, like, oh, okay, so the social biases are actually causing harm in these tangible ways that can be measured, and that is going to then allow us to, at least to some extent, correct these social biases. Okay, so what type of social biases are we talking about? So I've been a little bit vague about that. So if you think about what we're going to try to do, we're going to try to create a system. I don't know if you can see my mouse. It's like think of it as a robot. And we are going to, in the robot, we would ideally want to make a set of decisions as humans do, right? So what we're going to try to do is try to measure what our system or what our robot creates in terms of behavior. Because after all, if it's just words, if it's just biases, if they're just words, do we really want to go around and police people and their words if those words are not actually causing harm to anyone? We may still want to, but I think it's important regardless to be able to say what harm are they causing. So we're going to try to capture that with laboratory economic games, which my lab often works with, and we use for a lot of our research. But today I'm going to focus on, I think, probably the more important one that's certainly more accessible and relevant to most of you, which is real world discrimination in labor or education settings. Okay, so who's getting hired? Who's getting their, even something as small as who's getting their emails answered, right? All of those things are important for, people. Like, right, if I email my dean, I never hear back from him. Well, that's not a good thing, right? So our robot currently is, doesn't really know how to do any of these things. So what we're going to do is we're going to train the robot by having it learn about the real world. And we're going to have the robot learn about the real world through, in the best tradition of, I think, AI and these systems approach, by having it read the news. And by news, I mean all of the news. So it's like a robot that knows everything about the news, but that's kind of the limit of its knowledge. Or we can think of like a millennial or a Gen Z robot that where it only reads Twitter. So everything it knows about from Twitter, and it doesn't know anything else. Okay, so it's going to learn about the world through these large data sources. In this case, text, but it can be any type of databases that sort of reflects something about the real world. And what we want it to do is to make social decisions, like like the ones I just mentioned. And as an illustrative example, many of you might have heard about this. This was a seminal study back in 2001 that shows that was able to show very clearly kind of the tangible harms that kind of social biases can produce in the field. Right? So not just about implicit association tests or many of these other tests that you heard about, where things are implicit. These are kind of actions that people are taking that harms other people in some way, right? So this study is called "Are Emily and Greg More Employable Than Lakeisha and Jamal?" So it really is basically as the name says. So what the authors did is was that they took a resume, they took fictitious resumes, and they swapped out names like Emily or Greg and Lakeisha and Jamal, right? So if people are, you might think like, yeah, the names mean something, but it should really be the qualifications, the experiences, et cetera, that at least contributes most to the to whether someone gets hired or at least called back for interviews. And what they found was that names actually make a huge effect, and actually dwarfs any of the other effects about education or previous experience, et cetera. And what they found was that the white names receive 50% more callback for interviews than the Black African-American sounding names. So that's a really big effect, right? So this is the first, you can sort of think of this as the first cut in the interview process, and you're already seeing these huge effects. So this was just one study, and with just white or Black names. Can we say something more systematic? And the answer is yes. This actually happens. Is this going to move on? Oops. Okay. Yeah. And the answer is yes. This happens a lot more than just Black or white names. So this is a study in Canada of 44 race and ethnic names. Ethnic gender combinations of names. And what you can see on the left, the text might be a little bit small, but what you can see on the left is kind of a very rich set of variation between Caucasian names, Chinese names, Greek names, Indian names, Pakistani names. This is in Canada, so there weren't. I think the idea is like it was incredible to have so many African-American candidates in Canada. I don't know why they chose their particular names, but you can still see kind of a very rich pattern of differences across these names. And so one takeaway, yes, Canadians are biased too. Basically, everybody in the world is biased to some degree, and what we want to do is be able to capture this. So in our previous paper, we did very much this. We took a model of stereotyping, and we were able to predict these types of discrimination patterns. But what's more important for us is that, and I'll show you kind of the result, and then I'll flesh it out exactly how we actually came to these findings. So this is so what I showed you on the left is the observed rates of callback for different names. Okay, and so now moving to the right, the figure on the right is the observed and the predicted callback rates. So the predicted is using the model out of sample, the model of the system that we trained. And what you can see here is that we can actually predict these variations in callback with a pretty high level of accuracy. Certainly, I think 5 years ago, I would have thought that this was science fiction. And hopefully when you see exactly how we did it, I think you'll agree. So the way we're going to achieve this is by combining computational linguistic models on the one hand and social scientific models on the other hand. Right? So what we're going to do, the idea is that we're going to infer thoughts from the words that people use. Okay, so we're going to infer how people think about. I think the last one was like Joe Anderson, right? How do people think about Joe? How do people think about Lakeisha? Through the words that exists in these large text corpora, such as Google News or Twitter. And on the right, we are going to try to ask, how do these perceptions translate into observable actions? Okay. So the way I think about this is, and actually I think very similar to how, as human beings, one of the ways that we learn about the world is by reading and learning about the world through books, by watching movies, etc. Right? So we're learning about the world, and then we're going to have to convert these thoughts into actions when we actually, so if I learn about Paris for the first time, so I learn about all these things about Paris. When I actually go visit Paris, like, okay, this is what I want to do, etc. Right? So we want our machine to have this type of kind of very minimal type of awareness and ability and decision-making ability in kind of producing these types of behavioral outputs like resume decisions, etc. Okay, so this has been so we're building this on a previous study. I think it's still in archive. It's been cited now like 1,000 times, and but it's still kind of I don't think it's ever been. I don't think it's published yet. Still in a traditional journal. But I think the influence certainly is already felt. So maybe it doesn't need to be published in a traditional journal anymore. So what this paper did, this was a paper about quantifying and reducing stereotypes in word embedding models. So very shortly after word embedding models came out, people started noticing about these stereotypes. So the idea is that in these word embedding models, what I want to do is convert text data into kind of numeric representations, because I don't want to work with text data because they're complicated and sparse. And but what I want to do is I want to convert those into n-dimensional vector that contains kind of the semantic information, right? So these models, and I won't go into these models at all for the sake of time. I only have about 10 minutes left. So what these models do is, they take Google News, they train basically a co-occurrence model, a very fancy co-occurrence model. And they're going to convert these, every token, every word is going to be converted into a vector. So cat is going to be, 0.36, 0.55, whatever. Dog is going to be another vector, right? And the relationship, so now the vectors contain the semantic information, and we can use it to kind of perform sort of real world tasks. For example, analogical reasoning that you might have remember from your SATs or GREs. And below are some of the problematic examples that or kind of some of the awkward examples that they found, like father's doctor as mother is to blank, and the machine says nurse. Man is computer programmer. This one's pretty bad, I think. Woman is the homemaker. Black male is most associated with assaulted, and just to show that everybody gets a stereotype, white male is most associated with entitled to. Right? So basically, there's lots of stereotypes that these corpus, these large text data, and frankly, any kind of large representative real world data is going to contain about the real world. So it's not just about black or white, it's not just about man or woman, it's really every social group is being stereotyped to one degree or another, right? So what we want to do is be able to quantify this and relate it to observable actions in the real world. Okay. Right? Okay, so what we're gonna do, and this is gonna be real quick. If you're interested in the details, I'm happy to elaborate after the talk or send you our papers. So first, what we want to do is get these word embedding models that contain semantic information about, say, cat, dog, man, woman, etc., and convert them into social scientific measures of stereotyping. Okay, and what we're going to do is we're going to look at is these two dimensions of warmth and competence. And this might sound very strange to you. It was to me when I first learned about it about 5 years ago. That we all think of the social world as being incredibly complicated, and what social psychologist says is going to be like, no, it's actually really simple. Stereotypes, they're about 2 dimensions, or at least there are many other dimensions, but these 2 are by far the most important. How warm someone is, or how warm a group is, and how competent a group is. So the example that I give that so far has not insulted anyone, and you can tell me if you find it offensive, because it's very easy to offend people when you talk about these stereotypes, as you can imagine. So imagine imagine an Irish person and an English person walking through the door, right? Who would you say is the warmer person? Who would you say is like the nicer person? Every group I've ever presented to has said it's the Irish person who is probably more likely to be warmer. I even presented this even in London, where I presented this. Even English people think Irish people are warmer. So these and it can kind of give you a sense of how pervasive and robust these differences are. So the differences are not huge. So Irish compared to British or English is smaller, obviously, than, say, a pediatrician to an Irish. Right? So pediatrician, nurses, they're some of the most kind of warmest professions and social groups that we could find. But it is very systematic, and essentially everybody ranks Irish as warmer than British. Not everyone, most people. So that obviously should have an effect on how people behave towards Irish people and English people, right? So what we're going to do is, so the way I think about this, I wish I had animation in here, or at least I haven't been able to figure out animation. So this is kind of what we think. This kind of gives you a sense of the analytical process. So we're going to take warm words that are associated with warmth that we know from social sciences, like delightful, ethical, friendly, good-natured, etc. Non-warm words, corrupt, criminal, dishonest, etc. Competent words, not competent words. And we're going to look at how do those associations map onto stereotypes when we actually ask real people, right? So in the later data, in the analyses I'll show you, we actually don't take these type of lists. We train on say half of the sample of our social groups, and we try to predict the other sample. And just to give you a sense of the ideas of like what type of social biases people might contain. So this is from a couple days ago. Florida man, right? You type Florida man into the news and you see all kind of really bizarre headlines about Florida man. And our model should learn very strange things about Florida man, which I think is actually not so different from what many people's stereotypes of Florida man in the real world. So these are a set of targets. So the idea is we are going to train on, say, occupations. So the fact that I learn about where do people, and this is real human data on the left, okay? So people say that pediatricians are the warmest group, zoologists, veterinarians, and on the other side, mathematicians are some of the coldest groups, which, you know, I can kind of understand. Lawyers are cold, stockbrokers, auctioneer, least competent, most competent. Astronauts are thought of as very competent. I'm very happy to see neuroscientists are thought of as very competent. On the other hand, neuroscientists are thought of very cold. So I think you know, you can look at these, and I hope that they sort of make intuitive sense to you that, yeah, this is sort of where, you know, you might quibble with some of the specific locations, but the relative position of them probably, you know, makes sense. So Hawaii is the warmest state, not in terms of like temperature, but in terms of like, you know, people, right? And what I show on the right is the ability to, say, train on one group, say train on states and then predicting names, train on the warmth of states and predicting the warmth of human rating, the warmth of names. And on the right is our predictions of both warmth and competence. And what you can see is we're actually doing a pretty good job with out of sample predictions of these social stereotypes. So in this way, our system, the machine actually learns something about how people perceive other people on these social stereotypes. Okay, so now it has some idea of perception, and what we want to do is now link it to behavior. And the figure got cut off a little bit, but sort of the idea is that we're going to take these. So these are the observed. These are the names on the left. We are going to map the names to this two-dimensional framework of warmth and competence. These are recovered through our model. So these are the out-of-sample prediction for where the individuals on the right or on the left should line up. So for example, Michael Smith, Greg Johnson, Joe Wilson, etc., are warmer than, say, Asif Sheikh, Chowdhury Mohammed, Nali, etc. Right? And then what we're going to do is take this and move it to, and then use this to predict the resume callbacks, right? So now we have a system that is able to learn about the social world through it. Actually, we actually never trained on the names. So it learns about the world through through how people think about various occupations. And now I generalize, or the system generalizes to human names and makes predictions about their stereotypes, how society stereotypes them or perceives them. And using that, it is able to predict how society is going to behave towards them in terms of the resume callbacks. Here's another data set from higher education. So this one is actually stuff that I do. This is about professors' response rates. So professors are biased too, and professors respond to apparently white names more often. Our model is able to capture this as well. Well, what's interesting about this data set is that this bias is actually mostly in private school, private universities. If you look at public, they have a dummy for public university, and public universities are not, professors are not biased. So I have no idea why, but it sort of makes me feel good. And just lastly, one of the things that we're trying to do in the last minute is also trying to detect different biases in different corpora. Okay, so this is New York Times as of a couple of years ago, and we can see, New York Times has these social perception as well, and they're located on this warmth and competence space. And when we compared to Breitbart, this is where it kind of really shines through, that Breitbart really dislikes immigrants, really dislikes Mexicans. And I forget where Trump is, but Trump is like somewhere in the upper right corner. Like they really like Trump. Again, not surprising. So just to conclude, this is kind of a very, in half an hour, a very condensed version of kind of addressing validity challenges in statements about social bias in media and popular culture. That you see that everywhere, but as a social scientist and and also as a normal person, it's like, how much is this actually true? And what we show is actually there is a good degree of truth to it, but obviously there's a lot of sort of claims that are beyond what can be supported by data. So we can show that the AI and ML models built on naturally occurring text contain knowledge about social groups that correspond to human stereotypes. This knowledge corresponds to actual discrimination, so these are not just words, but they really do cause harm in some degree. And they're not just a result of data mining, because one very common, I think, suspicion that people have is that, there are so many, you look hard enough and you can find, terrible things in any corpus, right? And we show that this is actually not so much the case, that there is some representative, there is something that's representative and that can be potentially fixed, right? So some of the examples of future research, I think this opens up a lot of areas of future research. How do these biases evolve over time? How does the human brain achieve these capacities? That's something that we're studying right now. And how to de-bias these systems, both AI systems and also to some degree humans. Okay. All right, so let me see. I am gonna try to answer some of your questions. So let's see. Yeah, so we're out of the talk a little bit. Yeah. Oh, thanks for the link. I already opened the link. From Arbin, mentioned that there's a highly related analysis from another YouTube video, which would be great. Let's see. Anything else? Okay, so Nick asks, what can we do about addressing social bias in AI? So that's a great question. And I think what I would like to do is, so I don't know if you might find this unsatisfying, so feel free to let me know in the chat. I think what we need is to separate first what are social biases, and second, what to do about it. I think both of them are incredibly challenging, and one of the I think that the really unfortunate aspects of what's happening today is people are sort of mixing up both things, or people are talking about both things simultaneously. So we want to do something, but we don't agree on a definition of social bias, how to measure it, what are the effects. So then the fight ends up being kind of bouncing around between these two different poles. What I'm hoping is that we can, this can tell us, here are the tangible evidence for social bias. And then in terms of addressing it, there are actually a lot of ways but again, those are much more, as I think as scientists, I don't really want to say what we should do. So I'm just going to offer some options, right? So one way is you can tax, right? So you can tax certain types of behavior. You can strip out the information. That would be the extreme way. You can sort of correct, rotate, or like just strip out the semantic information. Okay. What I think would be another way, kind of personally, I prefer that one, is like, real human beings. I hope at least what I can do is I can say, okay, I look at this person, I have some stereotypes about them, or I think I want to do this, but I think some of my actions are driven by my emotions or my pre-existing conceptions, and I shouldn't do that. I should correct myself afterwards, right? So it's like building a level of awareness and kind of metacognitive abilities that our machines don't have it at all, right? So if that is and that's what we're hoping to do, because if we can do that, well, first of all, that gives us more work, and also I think that gives us a way of of not like censoring information, but which I think is like, I don't know how I feel about that. sort of like, but it sort of gives us a way of like, correcting it on top. Okay, so let's see. Francisco, Boris mentions, thanks, Boris. Boris mentioned that I hope your work will contribute to making things better. We definitely hope so as well. Francisco mentions that it's sad, how sad it is to see that, it is that easy to make the AI capture the social bias. I think that is, I share the sentiment, but I think it also gives us a sense of the scope of the problem and how difficult it's going to be to correct for this, right? So, you hear a lot about systemic racism, structural inequity. And, this is, sometimes people are kind of using those terms in kind of hand wavy ways. I think this is like kind of one example of how pervasive it is, that it is really easy to find. But I think it also should give us some pause about like, how much can we do right away, right? It's not just like marching in the streets is not going to fix everything overnight, which is what I think sometimes when I talk to my students. You can imagine, especially at Berkeley, that this is so pervasive, and but at the same time, it's also sort of by shining a light on it, I'm hoping that it'll make it much more tangible and much more concrete. What I really dislike is, if you can't tell already, like the very hand wavy way that people talk about bias. Raymond, I'm sorry. Yeah, Raymond says the inability to read the names. Yeah, this is I should have foreseen that in a virtual talk. It's gonna be hard to see the names. I should have blown it up as well. And oh wow, I'm gonna absolutely butcher your name. Trygve Holmsen, sorry about that. Asks, what would be the scientifically correct biases? Let's see. I think I'm gonna sidestep that question and say that these biases, social biases, or we talk about social biases in two senses. One is that it is kind of inaccurate, right? It is inaccurate in some form, and I think that may be what you mean by scientifically correct biases. But the inaccurate biases, I think, are a very maybe a minority. So this would be saying, like, if you talk to your grandfather or like your grandparents, people who are older, right, they'll have biases from like 1960s and 50s, and when we hear about them now, it's like, okay, it's like, yeah, the world has moved on since then, right? But there are also biases that may be correct in terms of the actual statistics in the current data, but they are not sort of either representative or they are selected in a way that kind of is meant to hurt someone. So this is what the first what the slide from what the example from Breitbart is meant to illustrate. Everything on that article could be true. It doesn't make it unbiased, right? We can see the bias very clearly. So this kind of gets into the really, so I think this is honestly one of the big hangups for a lot of the Silicon Valley folks I've been talking to. Like there's just such a focus on if it's accurate, I'm okay with it. And I think that's actually much too restrictive. Francisco just asked, have you done any analyses in other languages than English? That's a great question. That is a great question. We are trying to do that right now. If you have interest, definitely let me know. Part of this is, we need someone who's familiar with the language, and we need to find an appropriate corpus, and also validation data. most of this has been in English.